Okay, so in this video I'm going to show you how a simple example of how to find the centre of mass of a composite body, which means a body which is made up of more than one part. Now this might initially seem quite complicated, but if you have got a symmetrical body, so this sword that I have drawn is symmetrical along this line, okay, or would be if I had drawn it accurately. So that means that the centre of mass is definitely going to be along that line, so along the axis of symmetry. So that means that we can actually treat this as a one-dimensional body again. Okay, and we just need to think about the different parts of it and where their masses will be acting, and we can treat it exactly the same as the last example, where we can just treat it as a system of point masses. In this case, it's only got two parts, so it's just 2 point masses, okay, and it'll be quite simple. So, looking at what I've written down over here, the blade, this part, has a mass of 1 kilogram and its centre of mass is 20 centimetres from its base. So that means that we can say, right, the blade can be modelled as just a point mass, which is 20 centimetres, so somewhere about here, and we can just say there's 1 kilogram there. Okay, and that's 20 centimetres. I'm not doing a force here because I'm going to use that formula that I showed you at the end, so I'm not going to worry about G because I know it would cancel anyway. Alright, so that's the blade, and the pommel has a mass of 0.2 kilograms and its centre of mass is in its centre, so it's about halfway along it, which would be about here. Okay, and that's 0.2 kg, and we know that will be 10 centimetres, and that will be 10 centimetres. Okay, so we're now going to go back to our formula, so where we said that the distance of the centre of mass from the origin, so let's say the origin is here, the very end of the sword, the left side, it's going to be equal to the sum of the individual masses times their distances from the origin divided by the total mass. So that's going to give us 0.2 times 0.1 at 10 centimetre distance, plus 1 times, and that's 20 centimetres plus another 20 centimetres, so 40 centimetres, which is 0.4 metres. And we're going to divide that by the total mass, which is 1.2 kilograms. Now let's just shove this into a calculator. And we end up with, I should put that back there, x bar equals 0.35. So the centre of mass is about here of this sword. Okay, so the centre of mass of the sword is 0.35 metres or 35 centimetres to the right of O. We're done.